Yeah. Excuse me. Hello to everyone. My name is Taras Dubrava. You can know me as Taras from GIS Tech Exchange. And today I'll be talking about geocoding. I have prepared some slides, and I will stop today about. I will talk about geocoding. So I will explain what's geocoding. I'll show you some levels of expertise of how to geocode, how people do that, starting from novice level, ending with an expert. I will also show you some tips regarding the reverse geocoding in QGIS. And in the meantime, of course, I will demonstrate the geocoding QGIS. And if we have enough time, I will demonstrate geocoding using the Geopi library. The first slide that I'm going to start with a bit upset. There is a list of topics that, due to lack of time, I cannot elucidate, clarify today. So you still can go online and find some information about this topic. But anyhow, each of them is partially or fully plays a role in geocoding procedure. So what's actually geocoding is? Geocoding is a procedure of transferring your postal mailing physical address into a set of coordinates, a set of geographical coordinates, actually latitude and longitude. The opposite procedure of geocoding called reverse geocoding. So actually you take a set of coordinates like latitude and longitude, as I said before, and transfer them into an address. Geocoding, also known as forward geocoding or address geocoding, and reverse geocoding, people also call as backward or inverse geocoding. Each address may or may not lead to a point or even several points with latitude and longitude coordinates in decimal format. Sometimes geocoders define latitude and longitude as y and x. All return coordinates use VGS 84, more known as EPSG 4326. The process of geocoding many of points, locations, called batch geocoding. From own experience, it's better sometimes to geocode by building's name, like a POI name, if it has one. And there is a small list of domains where geocoding applicable. It's, of course, GIS analysis, geomarketing, then IT, logistics, and many others. So let's start with the first level of competence and novice level. As you can see on this slide, you can simply geocode using a tiled webmap service. You don't need that much knowledge about geocoding for that. You simply go online on your preferred tiled webmap service. You search for an address or a set of coordinates, and then the transformation will be going for you under the hood. So you wouldn't see any processes, and you will see the result. How does it work? A next stage in novice level for geocoding using a web page. So there are geocoding solutions available online. So a person actually can go to any of this website and bring own addresses or coordinates for geocoding. Some of this website will require or may not require an API key, and you can do the batch geocoding also with them, providing a path to your CSV file, for instance, or simply copy pasting the full bunch of your addresses. Then for maybe old school timers, you can actually even geocode with geographical coordinates grids. But I think this procedure will take you too much time because you will need to calculate all the degrees, minutes, and seconds using the coordinates grids. And of course, the maps that you use have to be topographic and with settlements on that. Actually, buildings with numbers and streets signed on the map. Then for you to to go on to the next step on stage of geocoding called advanced beginner. And here I just want to demonstrate how it is possible to geocode offline. Recently, many authorities provide their own data, actually government open data with addresses, and where you have address consisting of a street, building number, postal address, city, even a country. And you can actually join this data with yours. Simply saying you have Excel, in one sheet you have the government open data, and on the another sheet you have your own data. So using the VLOOKUP function, for instance, in Excel, you can bring the data from the authority provider page. But again, this is a pseudo offline geocoding, and there are a lot of problems that could happen because of the address, the way it's written by a user. Because the street, as you can see on this slide, can be written in so many ways. Even I didn't write them all, but just part of them. Another possibility using Microsoft Excel is actually can be done with a finished solution, which many websites also offer. So you can either download an Excel or make an integration into Excel. And I think Microsoft provide even some power map for that. Or in a second stage, you can actually use you can do a solution by yourself. For that, you may need some VBA knowledge. So now we are going forward, and the next stage of competence is a competent level of geocoding using GIS software. So today we're gonna discuss geocoding QGIS. So starting from QGIS 3.20, the Nomenclaim geocoder comes on board. It's available in as two features. The first one is Nomenclaim Locator filter, and the second one is the processing tool called Batch Geocoding Nomenclaim Geocoder. Sorry, and it's placed in the vector general of the processing toolbox. The developer of this tool is Matthew Pellerin. Correct me if I spell his name wrongly. And as you can see from the name, the Nomenclaim comes under the hood. And this is a tool for searching OpenStreetMap data by name and address, and also convert the set of coordinates into an address. Unfortunately, no heavy uses can be done. From my own experience, it's only possible to get 86,400 requests per day. So you do actually one request per second. The first part of this Nomenclaim geocoder tool is the locator filter. So if you go into QGIS, simply left bottom corner, and if you type a prefix, specific prefix, it's actually a less symbol, and you write any kind of like request, an address, a place name, or even coordinates. So it will pop up in the middle of the map canvas, and you can see the object that you looked for. The second one is the batch Nomenclaim geocoder tool that, as I said, can be found in processing toolbox. And now I will try to demonstrate how this tool works. Just keep in mind that after geocoding procedure, you will get a set of new attributes available in your newly created layer, point layer. And on this slide, you can see the description, what actually it means. So the tool brings some new fields from the OpenStreetMap data, and then you can see all of them in your attribute table. So I do a small jump into geocoding data. So I prepared a small CSV file with some data. I will show it firstly. Then let me jump in presentation in a bit different section where actually as I say, there is a CSV file called Geocoding CSV encoded in UTF-8. It has some data. It's actually museums around the world that were taken randomly. But the main point I would like to emphasize that address was taken directly from the museum website. So it's not address that I figured by myself. It's official address that stays in the museum website. So now let's import these addresses into QGIS. I will simply drag and drop it. Sorry. So I have it in QGIS. Now it's important to check the encoding for this file. Usually it works with QGIS detects your system encoding. I will use UTF-8 as it should be. Then I jump into the processing toolbox. Here I look for Nomenclaim geocoder. I choose my CSV file. I choose my address. And of course, if per person wants, he or she can save it straight. I will do it with a temporal layer, and then I press run. So in this processing toolbox, I can see that I have no result for several addresses already. There are already 3 of them, and now I have my results. So firstly, maybe let's have a look visually. So what I got in the end. And now I want you to go with me back to slides, and we're going to analyze the data. Analysis in sense of geocoding quality. So I will refer to each address by its ID. And as you could see, there are 3 results. There are no results. Actually, they were not geocoded at all. Then we have 3 addresses which are almost correct. Almost correct means they are somehow a certain distance away from our destination, from our target point. And of course, there are some successful results, and 4 of them are. Here in this table, I'm trying to show you that the failure, where it actually is, since we are working with OpenStreetMap data, you can actually find each location in Nomenclaim or in OpenStreetMap online. I actually found each of them and tried to figure it out what kind of corrections I need to apply to initial address. So as you can see, there are some huge problems in case of feature number 5 or feature number 8 or feature number 10. But also there are some tiny mistakes. For instance, feature number 3 or even feature number 4. And actually there is one small tip. You can actually find all those elements, all those locations simply by geocoding the place name. So if you geocode by museum name, you will find exactly the same location as in the table with success in the middle, big one. So in this slide, I'm showing you some suggestions or tips regarding geocoding QGIS with the batch Nomenclaim geocoder. So the first step you shall pay attention at, it's like the address from the official resource does not particularly mean that it's a valid address for Nomenclaim OSM. It's better to check the doubtful addresses in the nomenclaim. Sometimes better to search by point of interest name. And as I say, tiny things matter. And of course, you should expect no results or pretty poor results, where you will probably need to invest more time and to make your results better. So now let's go back to the last slide where I stopped about the nomenclaim geocoder. So here I'm asking myself a question: is it all? What to do if you want more? Simply saying that nomenclaim geocoder is not enough for our purposes, and we are not satisfied with the quality and maybe with the speed or something else. Actually, in the competent level, we will find a possibility to geocode with add-in in GIS software. So it's a geocoding tool from Saga provider. I actually have no experience with this tool, unfortunately, so I cannot tell you more, but it can be found in Saga's import, export, web services menu in the processing toolbox. And it includes 5 geocoding services: nomenclaim, the data science toolkit, then Google Maps, Bing, and MapQuest. Another possibility to geocode as a competent is using a plugin in GIS software. On this slide, I try to aggregate to collect all the plugins that I could find by text, by geocode, geocoder, geocoding, address, locator, and so on. So I split them into 2 groups. On this slide, you see the geocoder or plugins with world coverage, and in the bottom, you see more with local coverage. So this local coverage comes from country into country part into region or even a city, with example of Barcelona. And actually there are 26 of them. So in the next 3 slides, I'm offering you a possibility to view, to analyze, to see all the geocoders that I collected, the 26 of them. And of course, the headliner of all this stuff is mmqgis. I remember mmqgis from QGIS version 2. It was really cutting edge stuff, plugin that did a lot of things at that time. As you can see on this slide, I prepared some attributes which are also important for a geocoder. So I try to analyze by API key, whether it's required or not. I also sorted this table by downloads, then by the number of downloads. Also, you can see an attribute called geocoders. So I included all the names of geocoders that are available in this current plugin. Also, I included several attributes about whether batch geocoding, reverse geocoding is allowed or not, and extension, the coverage area. As you can see on this slide, most of them are world coverage. So this is the middle of the table. Now you see that countries appearing. The number of downloads, it's tremendously lower as it was before. And this is the last slide with geocoders available. And yeah, now you see like a number of downloads, just 200 to 300 something. So just few downloads available. And now we are moving to a next stage of our proficiency. So now we are geocoding using a PyQGIS. So the nomenclaim geocoder processing tool that I demonstrated you just recently actually can be run from Python console, either when you're using your standalone QGIS application or you're working in the Python console window straight in QGIS. So for that, you just need to provide the import of processing, and then you can simply run this native tool by specifying the field which you would like to geocode, which is, in my example, was an address. Now we are moving forward, and surprisingly, but starting from QGIS 3.18, it already had two embedded API geocoder classes. One of them is QGIS Nomenclaim geocoder, and the second one is QGIS Google Maps geocoder. Both of them were, again, developed by the same guru, Matthew Pellerin. And keep in mind that for Google Maps geocoder, a person will need API key. So in the next slides, I want to show you some difference between two of them. And actually, I'll start with some methods in common. So each of the class shares. After that, you can see that there are some unique methods for each of geocoder class. Both of these classes can be imported from QGIS core. So again, if you're working in standalone application or developing a plugin, you can refer to both of these classes by using QGIS core. Additionally, pay attention that some extra classes can be necessary or will be required while doing procedure of geocoding. And there are several of them that I found: this geocoder context, then QGIS coordinate transfer context, QGIS geocoder locator filter, and abstract geocoder locator filter. So on the left side and on the right side at the same time, I am providing you an example how these two geocoder classes work. So I took a random address, and as you can see from this slide, I'm trying to provide all the possible methods or attributes of this particular address. What can I get from the geocoder class? Keep in mind, for Google Maps, person will need an API key, which I specified here in red. And yeah, I got a list of methods. Thank you. Of course, thanks to Thomas. I found his answer really helpful on GIS Stack Exchange, and I could partially use his solution. And now, after geocoding, I could get several results, actually 3. Now I will try to explain why. So actually, the Nomenclaim geocoder can sometimes be a bit more complex. As you can see, the class of each record has different meaning. So the first class is the tourism, and the second class is the building. So these both objects located at the same address. Actually, I know this place, and this is the same building. And at one part of the building, you have a museum, but another part of the building just a normal office building. So at the same time, you get 2 records, but everything is fine with Google Maps. So you get just one result for this address. Yeah, a small suggestion how you can avoid those kind of ambiguity. You can do a filter. You can apply a filter for your result, and then you will end up just with one record. So now we're going a bit even more further. Actually, it's funny because during this geocoding stages that I showed you, I was mentioning some different companies, like Google Maps, Here Maps, and other companies that are available. And actually, each of this company has its own geocoding API. So you can actually access each of the geocoding API having an API key, of course, and correct URL for that. And you can do geocode by yourself. So the thing you need is probably like addresses and the approach that you use, of course, the programming language of your choice, and you can achieve the results. Here I'm showing you a bunch of geocoding API where an API key is required. In comparison to the previous slide, here I'm showing you the geocoders which are free. And yeah, you can access them, but again, the data quality, as was shown before with Nomenclaim, is not always the best one. However, I would like to emphasize here a small tip. So all the geocoders that you have seen on the previous slide can actually be used in a certain way, for instance, for your personal testing purposes. Of course, it can be limited in sense of number of requests per day per second, the purpose of usage, of course, the level of support from the provider, maybe all the errors, bugs you will need to figure out by yourself, and also the variety of response formats, and also other restrictions. But again, it could be absolutely enough for you, for your project, for your master thesis or bachelor thesis, etc. But be careful, pay attention to terms of use, privacy policies, and license restrictions. Now we are jumping to an expert level of geocoding. Of course, you can find many more libraries available on the Python package index website. I just chose Geopi because of my personal preference and of my personal experience. But as you can see from this slide, there are 50 projects for geocoding available with the production stable status. So maybe you can find something better for you. Why do I prefer Geopi? Probably because of its documentation, ability to connect with pandas. It also includes possibility to be asynchronous, which is quite popular topic for nowadays. By default, all of the geocoders are synchronous. Geopi also contains a huge list of geolocation services available. Here on this slide, I try to list them all. Actually, when you are doing geocoding with Geopi, you can refer to address, latitude, longitude, and raw output of each geocoder. Doesn't matter which one you use. So they are standardized in that sense. Actually, there is a small extension for Geopi. You can calculate geodesic distances between 2 points using some popular ellipsoidal models. And last but not the least, you can integrate this Python package into QGIS. The reason for that I will show you in a couple of seconds later. So as you can see now, QGIS meets Geopi. I provided some links where a person can understand how to install Geopi as a third-party package in QGIS. And after successful installation, one can use Geopi directly in QGIS. Another package that I would like to mention is requests. Actually, it's already included in QGIS. So if you type import requests, you can actually use it straight. It's not a native package for Python. You need to install it with pip, or I think with Conda also possible. But in terms of QGIS, it's a native. It's already included there. So if you have an URL, if you have a link to your geocoding API, you can use it straight by using the requests package, simply doing by get. And then you will need to use some JSON parser for that, but it's much more easier that as you can think. As I mentioned before, there are some reasons for using Geopi or request packages in QGIS. I'll go back in a couple of seconds. The reason is actually the reverse geocoding. Of course, person can use a plugin which can be much more simpler. Another possibility, as I said, it's using Geopi request. So you write a custom function in QGIS, and then you send a request using the latitude and longitude, and you can get a result of your address as an attribute table. And also, a nice answer can be done with joining addresses. So as I said at the beginning, there is much data available online from government open data provider, which you can find specifically for your region, your country, your city. And you can upload that into QGIS as a delimited text layer. And then afterwards, you can do a joining the nearest. And that can be sufficient enough for your task. And there is a specific function for that called overlay nearest. And back to previous slide, here is a stage one level of competence, which is not included in the main section, but also assigned for later, for future. I would really like to appreciate Pedlias for doing a nice job in geocoding domain, and also Docker. And the combination of them both can have a tremendous impact on geocoding procedure of your own. So now we are going forward. We already discussed the geocoding in QGIS straight. Now we are moving forward into geocoding with Geopi. I will be using the same CSV file as I used before with museums, with their addresses. For that, I'll switch into PyCharm. So I wrote a small, tiny script. It's nothing spectacular, just raw code. Here from Geopi geocoders, I'm importing 5 geocoders. ArcGIS, Bing, Google, here, and Nomenclaim. I could get some API keys for them. Yeah, for my personal training and my projects. I saved all the API keys in the authentication YAML file, which I'm loading now. Then for each geocoder, I created a separate function that does geocoding. So here I have Esri, I have Bing, I have Google, I have here, and I have Nomenclaim. So after I set the geolocator with API key, if it's required, in case of Nomenclaim, person should use a user agent attribute. And then I'm going to geocode, which is a forward geocoding, address geocoding. And then as a result, I'm getting 2 parameters as a tuple of latitude and longitude. So this CSV file, I'm gonna read with pandas and then export the results in a specific folder called export here, as you can see. Maybe in the next several rows that you will see not that efficient in the sense of typing. I just did it really hard-coded, so there are probably better ways of doing that. But simply saying in each part, I tried to apply geocoder for an address attribute, and then I did it with a location attribute, and then from that location I got latitude and longitude. I strip and I got the part of that. Then I'm dropping this field, which I don't need anymore. And in the end, I'm exporting again back to CSV file. So each geocoder will produce its own set of coordinates, latitude and longitude, and I will then analyze each of them separately. So we can actually run it, but I did it yesterday, and I already have results, like 5 of them. To import all of them into QGIS, I will do it with a small script that actually reads or takes each of CSV files and imports into QGIS as a new point layer. Let me copy, paste it into QGIS. So firstly, I will change the lightness of the background map. Now let me delete the result of previous geocoding procedure with Nomenclaim geocoder tool. Now we're going to Python console and pasting this script here. And now I will be reading each of CSV files separately and uploading them into QGIS. So let's run it. Good, I got something. So as you can see, I just turned off the map. So what is the best result I could get? Probably here in Canada or in America. So this is all locations of our geocoding procedure. This is for one museum in the US. And here you have 2 locations from, who is that? No, I think it's Google. Yeah, Google is outside of the building area. And also here, it's also outside. All of others, mainly Nomenclaim, S3, and Bing, is inside. So let's go back to presentation. As I said, I uploaded all of the results CSV files back to QGIS, visually demonstrate where they are, what are the results. And here I prepared a small table showing how good are they. So the Nomenclaim we already have seen before. There are a couple of results, there are no results, but others are pretty poor and weak in comparison to others. Because in the previous table, I did it with orange color, but now I'm doing it with a red, because in comparison to others, they are just nothing. They are too far away, either 60 or I think 30 kilometers. It's not sufficient for me. Yes, no means there is result, but it's not enough to be good. And as you can see, there are several where none of the geocoders could do that. So it's number 5 or 10 and 10. Actually, number 5 and 10, it's the museum in Bangkok, and number 10 is Cape Town Holocaust and Genocide Center. As in the previous example, I am also giving some suggestions for geocoding with Geopi. Again, geocoding by point of interest name can be robust. I would like to emphasize that the story with styled webmap services should not repeat. So there are other geocoders, not just Google Maps, that could actually do the job even better than Google Maps. I'm not working for none of them, but just saying that there are some other options. Of course, choosing a geocoder can be a subjective topic because it depends on the area of coverage where the company, the geocoding service provider, has better coverage, has better quality, and has more data. For instance, geocoding in Jamaica can be good with one geocoder, but at the same time can be really bad in Slovenia. So you will not get that much results. Of course, you should expect poor and non-results at all. Perhaps from my point of view, combination of proprietary and open source solutions is also a good solution, attempt to do geocoding. And yeah, it doesn't mean that much to round the coordinates, but everything that goes after the 6th digit is meaningless. So you don't need that much digits after the comma. Here, next stages, I will try to write some comments in my code and do some improvements on the presentation itself. And as soon as possible, I will upload all the data to the GitHub. I'll be doing also presentation in QGIS channel on Discord. I don't know when exactly. And of course, I will be training and practicing by answering questions on GIS Stack Exchange with several tags available, geocoding or reverse geocoding. Additional thanks to Julian Monticolo for reviewing and my presentation and helping me with some terms, technical terms. Of course, thank you all for having me, for your attention. Please, if you have any questions, suggestions, or comments, please pop up or contact me in your suitable way. Thank you.
Thank you so much for a great talk and very comprehensive coverage of the geocoding landscape. It's really amazing to see so many different tools available for our users. I wondered if you would like to make a comment about these geocoders, like what 3 words? Do you have any opinion on them? They're quite divisive in the community. Do you have any thoughts about the value and validity of what they produce?
Which exactly geocoders?
Or what 3 words, for example, and the other ones which use this sort of tile-based approach?
Sorry, I cannot understand your question, actually.
My question is, there are tools like what 3 words? I saw it mentioned on your slide. Do you know this tool? What 3 words? I'll write it in the chat for you.
Yeah, but which slide was it? Can you
I'm just writing the name of the geocoder in the chat there for you.
Yeah, three words. Yeah.
Yes, I'm asking what is your opinion or thoughts on geocoders like this, which are kind of commercial and have some divided opinion about whether they're good to use or not?
Yeah, I think it depends how much data you need or how much data of yours should be geocoded. If it's billions, trillions of points, then performance plays a key role there. And maybe you need to go to some gurus of geocoding, like TomTom or Google Maps or here. But if you're doing a tiny project and performance is not that problematic in that sense, so you can do it with less known but also good one.
Thanks. I was asking more on a sort of philosophical level than a practical level, because some people complain that, for example, geocoding doesn't produce In the case of what 3 words, like a string, which is always very clear, or can even, I think, have some duplicates in the geocoded outputs, or very closely similar geocode expressions.
Mm. Yeah, I still barely understand what do you mean with 3 words, like philosophically. Sorry.
So, okay,
I'm a bit out of topic.
The service, what 3 words I'm talking about? First, are you clear on this? What 3 words? It's a commercial service for providing geocoding, but it gives you back 3 words.
3 word. Okay, 3 word.
Okay, if you don't know it, then don't worry.
No, I don't know. Sorry.
Okay. And then we had also a comment from the chat on YouTube saying that there is also Yandex's geocoder, which has a limit of 1,000 free requests, but also seems to work pretty well. I don't know if you have tried it out or experienced with it.
Yeah, due to some circumstances actually of the war, I'm not providing any information about the Yandex at all. So I know about its existence, but I'm not providing anything about that.
Sure. And otherwise, there were various comments saying thank you very much and excellent presentation, and just positive feedback basically on all the great information you've shared today. I don't know if there's anybody else that's lurking in the room with us, Ethan or Hazel or Mark-Catherine, if you have any questions. Otherwise, we can call the session to an end. Okay. So Taras, thank you very, very much for taking the time to present today and joining the QGIS Open Day. It's really appreciated and really exciting to see how much possibility there is in QGIS for doing geocoding work. So I hope you'll come back again and update us on the latest developments sometime in the future.
Thank you so much for having me today. It was a pleasure.
Thank you. All right, and thanks to everybody who joined in the room and in the chat room on YouTube. We'll see you in the next session. Starts in about 10 minutes time, and it will be a catch-up with the Netherlands QGIS user group, and I think it'll be more like an open forum session, so we look forward to seeing you all joining there. Thank you, and bye-bye.
Thank you.
Thank you, bye-bye.
Tim, a small question.